All right, I think we are live. Hello, hello. Let me just check one thing. All right. So, hello everyone. Welcome, welcome on the channel. And today's stream, we will learn about WebSockets, how we can implement them in Rust. So, we will start from scratch. We will learn. Uh, so, without any delay, let's get started. Hmm. So let's understand WebSockets. Uh, let's be more specific in this. WebSocket in Rust are implemented using mature high performance libraries that leverage Rust memory safety, async await model for efficient, scalable real time communication. Amazing. Tokio Tungstenite. Early Revdo solution for async WebSocket implementation is similar to Tokio runtime and provides a clean production ready API. For those who don't know what Tokio is async runtime uh, that you must have heard if you're working with it, like if you're working with Rust. So if you want to create async environment, then you have to use Tokio. Okay, so this is one I got, like I heard of it in today's stream in morning. So we will check this out. We have this as well, Rust WebSocket, an older experimental library, Tungstenite RS, a lightweight bare bones WebSocket implementation. So I think Tungsten RS is what Tokio is wrapped on top of it. So it just created this, I think. Best practice async await Rust async await model powered by Tokio enables handling thousands of concurrent WebSocket connection efficiently with a minimal overhead. Memory safety, performance, compile time safety. Amazing, all these things. So we need this Tokio, of course, Tokio Tungstenite. All right. So this crate has both async and sync implementation. If you are free to choose, all right. So we'll start with this thing. Let's say Rust WebSocket is a WebSocket. Rust. Okay, clients to make clients use client builder struct. The builder has method. Mm-hmm. 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 WebSockets result async client codec. Okay. Hmm. Okay, there's a code piece. If I use Tungstenite, it uses connect and message. Connect. This is connect socket dot write message, and this loop I think will listen on all the messages. So write message is this text. Mm-hmm. Okay, so cargo run example server, separate terminal this, and they are going to, but this is Rust WebSockets. It's already mentioned over here, I think. Rust WebSockets. But this one is the most widely adopted solution for async WebSockets. Let's search about this thing. stream based. Each WebSocket connection is represented as WebSocket stream, which implements both stream TLS support. Offers secure WebSocket connection via optional feature. Hello, hello. What's up? So this is the listener. I mean, this is the server, right? WebSocket server. Now here, what it does. Okay, so the listener is TCP listener, Tokio net, and spawn. Okay, accept async. This one will be from Tungstenite. Then it just split the stream, so it says it works like as a WebSocket stream. And if I split it, it returns a tuple, write and read. And this is just waiting to read the messages. So this one would be a server, separate somewhere would be, this must be a listener. And, you may also want to get familiar with Tokio if you want. Tokio Tungstenite, okay. This grid is based on this thing. Rest will provide Tokio as it is TLS is supported on all platforms using native TLS or Rust TLS through feature flags. If the performance is escaped by the provider. As a decent performance, it has been used in production for real-time communication software, video conferencing, but it's definitely not the fastest WebSocket library in the world at the moment of writing this note. We are aware of the change that both this and this requires in order to make it on par with slightly more performant libraries like fast WebSockets. In the course of past years, we have merged several fast WebSockets. Damn, high performance WebSocket for us implementing RFC protocol. It is designed for speed, minimum overhead, passing. I mean, this is being for. database building a multi-threaded GPS service in Rust. What do you think? Hello, hello, Bhargav. I don't know, Mukherjee. Don't know. So it turns out fast WebSocket it is the actually more one like slightly faster than this thing. Enable one of them. Okay. Hmm. Implements the required stream and sync traits. So the socket is just a stream of messages coming in and going out. Connector that can be used when establishing connection, allowing to control whether just to create a real connection. TLS can be maybe TLS is a string that might be provided with okay, accept async provided stream. These are the functions. Connect async and accept async. So here is the scenario. What if someone asks you to create a chat application or using this WebSockets using Tokio Tungstenite? How do you do it? So we are going to figure that out. All right, so let's do that. So these are this thing, right? So I think we need to have this thing. Uh, let's start with this thing. So uh, let's add this. What else do we need? Q and Tokio Tungstenite, these things. So this is the simple example server. So let me just so let's have a problem statement here. I hope you guys can see it. Let me just increase the fonts. That would be good, I think. Yes. So the problem statement is create a chat server using WebSockets in Rust. So let's try to do that. Think of it as a question someone asks you, or you know. So we just looked out for some resources, and Tokyo Tungstenite is the one that is on the top of search result. And but when we go through the documentation, it turns out that there is another library that is called fast WebSockets, that this thing is referring to. That okay, this could be it says that the more recent version of Tokyo Tungstenite are more performant and should be more on par with fast web sockets. So it means it holds some accountability of being performant or fast web sockets. So we look to it, and you know there is something going on here. Fast web sockets, so it is something like that. TCP stream is from this thing, connect localhost. So but we are going to use this thing. Let's try to implement this thing with the help of this. Okay, we'll just search how a normal dev would do without taking help of an AI. How would you approach to a problem? So this is an example server that is written over here. Futures, sync and stream. So we just read somewhere that these two features, like these two traits are being used, sync or stream. I think it was on the documentation over here, right? Yeah. Each WebSocket stream implements the required stream and sync traits. So the socket is just a stream of messages coming in and going out. Hi, hello, welcome back. No, I just started stream few minutes back. I took my day off. I mean, some time off. Um, so I don't have any like hands-on working experience with C++. I have the experience with Rust. So, but again, if you are very comfortable in C++, go with either of them. Whatever you find like comfortable working on. Like before directly like jumping into you like in low level. I mean, if you are comfortable or if you are like aware of all these things or have like ever worked on any low level language, then it's okay. But if not, then you should start with something like Node.js, so that you get the idea how a client and a server connects to a socket, what are like rooms and all, how the message is propagated, how a listener accepts to the message. Like you create a WebSocket connection on the Node.js server, and then from the client side you send the messages, you create rooms for the users so that they can all join in. You broadcast the messages. So if you are uh, not very well, or not very well in the sense, if you haven't worked on any low level language before, you should try that first. If you like start working with Node.js, it's quite simple to work on with WebSockets. But if you go very low level, then just like I'm doing, so you might encounter some of the terminologies, some of the concepts that are like very overwhelming at first. Yeah. So okay. So it says, and Tokyo Tungstenite, I think we have just read it on the very first Google search that it acts like a WebSocket as a stream. So, and on the Tokyo Tungstenite, it says each WebSocket stream implements these two traits. So we will figure out what these two traits are, right? So maybe we can search it over here. Stream and sync traits in sync in futures. Stream represents a value that can be processed one at a time. It is the async equivalent of iterator in standard library. Okay. Hmm. So it's an async equivalent of iterator. So what iterator does is it kind of works on each value one at a time, but synchronously. And on the other hand, its asynchronous version would be stream. Stream trait defines like poll to check for new items, returning a poll of option of items. Okay. Incoming network packets, repeated timeouts or incoming connections. Example, a TCP server that processes each incoming connection as it arrives. Streams are typically consumed using commutator like for each collect port. Okay. Sync. Sync is the opposite of stream. It represents the destination for sending asynchronous value. Okay. So stream and sync are basically read and write. Sync is the opposite of stream. So streams checks on incoming messages. What? Incoming net, yes. And this sync is the opposite of stream. It represents a destination for sending asynchronous values. Use case, sending data over a network socket, writing to a channel, or writing to a file asynchronously. Okay. So if we want something to create something that write to a file asynchronously, and if it's an async thing, then a sync trait should be implemented under the hood. Sync often use internal buffering to handle cases. Okay. Relationships and using stream sync. The most common pattern is to send an entire stream to a sync using send all, high level combinator provided by sync ext. Both traits put back pressure. When the sync is full or a stream is slow, the system pauses processing until resources are available. Combinators. Okay, combinators. I think it's in. Okay, it's connectors. The future crate provide extension trait like sync ext, stream ext with useful methods such as buffer, fanout, with, and send all. So I think sync ext and stream ext are the combinators that is being used in this example. Where is it? This thing, futures. Okay, bind. Okay, it started a server. This is the listener, and it accept a stream. Now this stream accept async. Wait. So shall we check this out? Okay, you know what? Let's just. Hmm. So futures, nothing. Okay. WebSocket stream. Okay, so this will return a message, right? So it's listening. So if someone going to connect, or if I open another like server, then this should return a message whatever I send it from. So we do not want to send back ping pong messages. Take a look at example section. Where is examples? Okay, so there are clients and server, right? So this one is the server. Received a new WebSocket handshake. Okay, let's understand this. Server dot incoming. I need to write it. I think it's just the plain, like it's a plain Tokio server, right? Mm, what is like? Let me just. Do this. Yes, I got it. It just returned back. Okay, now it's I think polling. Should I see it again? No, there is no such thing. It says it panicked. Result.unwrap on an value. Missing connection upgrade header. Okay, so I think this is a plain server, so we have to create a server like this. Stream server.incoming. Hmm. Here is this thing stream.unread WebSocket accept. Mhm. Connect to this slash socket, and this is just write the message and read it, so it's a two-way communication. Just wait a minute. Connected to a server. Okay. So it took her from Tokio Tungstenite. Create the event loop and will accept connection on try socket. Okay, listener, try socket dot. Okay, fail to bind. Listening on this address. Hmm. Let's spawn the handling of each connection on in a separate task. Hmm. Stream and the address is Tokio.spawn. Handle connection. Let's go on this thing. Okay, now this. Okay, so this accept async will have this WebSocket stream. This WebSocket stream, and here it just split into outgoing and incoming. Into that's okay. Outgoing read write. That is now it says incoming dot try for each received a message from blah 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 message dot text address and message try for each. We want to broadcast the message to everyone except ourselves. Okay. So insert the right part of this peer-to-peer map. Peer map.log. Okay. Address to this transmitter. The address of the incoming request. The socket address. These are the peers. So it uses peermap.log, so it's been wrapped in mutex. It's a hash map of socket address and the structure. This is a simple line-based server. Fair. That is okay. Now this peers is the hash map that has all the addresses that are going to connect to this. So it's maintaining a hash map. That hash map will have address of all the peers as a key and a transmitter to it, because it has been on a separate task over here, right? So each connection will have its own address, and that own address will have a transmitter. So when I broadcast, I will loop on it on that hash map, and I will just send the message. That is good. This makes sense. So this is how it deals with it. Now let's see the client. A simple hooking system will connect to a server specified in the argument list, and then forward all data. Okay. This example together with this server example. So it connects to a server. This URL would be the one of server. And again, it has read and write, so client can also send the messages. And once a client sends a message, the server will broadcast to all the peers that are there on the hash map. Right. Yep.